Hello, 8th grade. It is me, Miss Beck, and we are going to attempt to do CPM online through videos. Fun. Okay. First lesson up is 7.1.2. That's the first one I have assigned since we did 7.1.1 at school with the whole circle graph and the string and all that stuff on last Friday. Okay, so we're doing 7.1.2. We have 3 problems to get through. 7.13, 7.14, and 7.15, I believe. Yep, that's it. I've already drawn the scatter plot for this, just for the sake of time. But you can ignore that for now because I'm gonna just be reading. If I'm looking over here, I'm looking at my CPME textbook. If I'm looking over here, I'm looking at the work that I've already done for this lesson. And let's get started. You can pause whenever you need to and give me suggestions on next time if I need to move out of the way or need to adjust the camera, zoom in more, let me know. This is kind of our trial run. Okay, I'm reading right from the textbook, so if you have your textbook out, you can follow along. 7.1.2, is there a relationship? Organizing data in a scatter plot. In lesson 7.1.1, you looked at single data sets such as world population. Often you need to compare 2 measurements to answer a question or to see a connection between 2 types of data. For example, comparing the odometer reading of a car to the price of a car can help determine if these factors are related. Odometer means the amount of miles that are on a car, so the amount of miles that the car has driven in its lifetime. In this lesson, you will study scatter plots, a new tool for visually presenting data as a way to relate 2 sets of measurements. You will be asked to analyze the data to see if you can make predictions or come to any conclusion about the relationships that you find. So it says as you work with your team today, use these questions. How can I organize the data? Can I use the data to make a prediction? What does a point represent? And is there a connection between the 2 variables? So we're starting with 7-13, our first problem. And it says, how much is that car? And I'm going to read it for you. Nate and Rick were discussing cars again. Nate claimed that cars with low odometer readings were more expensive than cars with higher odometer readings. His evidence was that his car with 23,000 miles was worth more than Rick's car with 31,000 miles. To investigate Nate's claim, the boys collected data from several car advertisements and found the information in the table at right. So in your book, you'll see the long table that's titled Nate's Data from Car Ads, and it has the odometer reading on the left and the price on the right. The question is, does the information in the table support Nate's claim? That is, do you believe Nate's claim that cars with a lower odometer reading cost more money? So what I started writing down, because that was a whole lot of information, so I wrote down, I started writing down things I knew. So I knew Nate's car had 23,000 miles. Whoa. And Rick's car had 31,000 miles. And based on just the odometer, Nate thinks that his car would cost more and Rick's car would cost less. So now he's going to look at the table, and we can look at the table. And I'm looking at it, and I'm like, okay, cool. It's kind of hard to organize your thoughts around it because it's not easy to visually see just by looking at the table. Oh yeah, the thousands of miles on the odometer affects the price in a certain way. You'd have to really organize it, and we don't want to do that. We are learning about scatter plots, which are going to help us visualize it better. So if you do want to pause it to draw the scatter plot, you can right now, but I have drawn it already for sake of time, and I've plotted the points. So down here, our X and our Y. Our X-axis, I labeled as the odometer, so the thousands of miles that the car has, and this Y-axis is labeled price, and this is also in thousands of dollars. So this does not mean the price of the car is $10 or $20. That's in thousands, so 10,000, 20,000, 30,000. Same with the odometer on the bottom. So then I started taking points from the table. So the first values are 35 and 38. So I went to 35 on the X, found it here, and I went up to 38. Ooh, is that 38? I think I put it here. Yeah, so there, I wasn't exact because it's not ideal with the whiteboard here, but 35, 38, and then I put a point. And I went and threw all the values and did the same thing. So the first number is your x. So the next values are 55 and 16. So I went all the way to 55. And then I came up to about where 16 might be. And I put the dot. I did that all the way down the line. So if you want to kind of do that now, you can pause the video. But we're going to move on to answering the question now. So now looking at the scatter plot, you're going to respond with, and you can write it down now, do you believe Nate's claim that cars with a lower odometer cost more money? So you can read the graph, you can see here's the lower odometers, and it starts to get higher and higher and higher as you go down the x, and the price for the y axis is lower down here, and then it goes up and up and up, and here's our most expensive car. Okay, and it has a pretty low odometer, and what I'm noticing with my eyes is the graph, there's this kind of like downward trend going on. So it does look like as the odometer goes up, the price is going down. So that means that a car with a lower odometer would probably have, sorry, that's my dad's work phone, a lower odometer. Just based on this graph, I would say yes. Cars with a lower odometer cost more money. Just based on that graph alone. I am now going to show you with my red marker. It's a new strategy with a scatter plot, and it's called the line of best fit. So a line of best fit in general is just a line that you can draw through the points. Not exactly through the points, but kind of you're noticing a downward trend, and my arm is kind of like showing the downward trend. We're gonna draw a line that kind of represents this downward trend, because that's what I see with my eyes. So a line of best fit, I would start it here. Let's see, I wanna make sure I do this right. 1, 2, 3. It's not gonna be exact because my graph is not very exact because I didn't make enough room for my y-axis to have 100 over here. But that would be our line of best fit for this scatter plot, because there's about the same number of dots above and below the line about. Again, this is very rough because my graph is a little off, but in CPM, the CPM book states that the line of best fit for this graph would have about 3 points above and 3 points below the line of best fit. Okay, so that is that. For 713, it was kind of a dense problem there. But now we're going to move on to 714, and I'm wondering if I need to leave this up. Yeah, I'll leave the graph up. Eraser. So I'm going to erase just this top part. And we're going to move on to 714 in black. There we go. And I'll read it. Melissa looked at the data from problem 713 and said, I need to be able to see the data as a picture. I cannot tell if there is a relationship from the list of numbers. She decided to use a box plot. Her box plots for odometer reading and price are shown below. Do these pictures help you decide if Nate is correct? Why or why not? Box plots are, let's do a quick review of box plots. I'm not going to get really into it because they can kind of get a little confusing, but I'm going to give you a gist of what a box plot is. It is a method of organizing data. So I'm going to draw one, and you can draw this as like notes if you want. So it'll usually have a box, and then it'll have a line somewhere in the box. It's not always right where I just put it. I just put that as an example. And then it has sometimes it's called a box and whiskers plot, kind of like a kitty. So like whiskers on the end. So here's our box and the whiskers. And then this line represents the minimum data point in your data. Say you had like 0, 1, 2, 3, 4 as your data points. 0 would be your minimum, and this would be like on a number line. So you would see that, oh, 0's there and all that other stuff. This would be, if this is your minimum, this has to be your maximum. So if our data was 0, 1, 2, 3, 4, 4 would be our maximum data point. Okay, now this middle line that I drew is the median. And the median is the number that is in the exact middle of your data if your data is in numerical order. So I kind of did it nicely with this one. 0, 1, 2, 3, 4, they're in numerical order. And the one that's exactly in the middle is 2. So our median for this data would be 2, and that would be represented on the number line somehow. And then lastly, and I'm not going to get too into this part, this line actually represents the first quartile, kind of like the word quarter, and this one represents the third quartile. So that's just a fancy way of saying that this line represents 25% of the data, and this line represents 75 percentile of the data. All right, so that is box plots in a nutshell. And now it wants you to look at the box plots that it's showing you, and it's just asking, do these pictures help you decide if Nate is correct about odometer and price? And you can think about it for a sec. You can pause it right now. But I am going to tell you, just by looking at those box plots that I'm looking at for 714, the box plot is not going to be helpful for this data because it does not allow you to relate the two sets of data. So I'm looking at one set of data here. This could be just the odometer readings, or this could be just the price readings for the last problem. I don't see my two sets. There's two sets, odometer and the price, and I'm not seeing it with a box plot. So box plot is a no-no for this problem. And I would say box plot is not helpful because it does not show two sets of data. But you'll notice our scatter plot does very nicely. Okay, so that is 714. And I'm going to erase that now. You can pause it if you need to. And we're going to do the last problem. Phew, I'm not used to talking so much. I need a drink of water. Okay. All right, 715 is our last problem. Okay. So if you do have your computer and you're using CPM, the e-textbook, you can use the e-tool for this, but this is pretty much what the e-tool is showing you. So if you've already drawn your graph, you don't need the e-tool. So 715 says, Melissa wondered if a coordinate graph could help determine if there was a relationship in Nate's data from 713. Part A says, follow the directions below to create a scatter plot of the data for Melissa, or use the e-tool. Click in the lower right corner of the graph to view it in full screen mode. So we've already done this. So if you've already drew your graph, for part A, you can say C graph in 713, because we've already done that. We've set up our graph, we've labeled the axes, we have equal intervals. I did it by 5, so I did 5, 10, 15, 20, 25, 30 for both axes, and we plotted the data points. So part A is done. So now we're kind of going to be doing some writing now. So part B says to describe the scatter plot you just created. What do you notice about how the points are placed on the graph. Do you see any patterns? So you can pause right here and write down what you think. What I'm noticing, and what I've said before, I'm noticing a downward pattern. So I notice the points are following a downward pattern. So that's part B. Now it says to place an additional point on your graph for Nate's car that has an odometer reading of 23,000 miles. Explain your strategy for deciding where to put the point. Okay, so let's do that. This is part C. So based on what we see, so I'm looking at the graph, I'm gonna find 23,000 miles. So that's down here at about this area. So now I'm gonna make my little prediction of where I think the price would be. And I'm gonna put it kind of where my dots are up here because it's following that downward pattern. I wouldn't put it way up here because that doesn't match the pattern. I'm not gonna put it way down here because that doesn't match the pattern. So I'm gonna put it maybe like right here. So that's my new dot. And I decided to put it there because it followed the downward pattern. So you can write, I put it there because it followed the downward pattern. Okay, we're almost done, just a couple more. Okay, I am going to erase these so I have more room. Getting hungry. Okay, part D. Whew. Part D, I'm gonna read it, but it's basically what I was talking about with the line of best fit. So I'm gonna read it. You can skip through this if you already kind of get the idea. Part D, when a relationship exists, one way to help show a trend in the data is to place a line or curve that in general represents where the data falls, like our red line. This line, sometimes called a line of best fit, does not need to touch any of the actual data points, and mine accidentally did. Doesn't have to. Instead, it shows where the data generally falls. The line is a mathematical model of the data. Models of data help you describe the data more easily and help you make predictions for other cars with different mileages. It says, with your team, decide where a line of best fit could be placed, sorry I spit, that would best model the data points. Are there any limits to where your line makes sense? So I'm just gonna label this as our line of best fit because that's a new concept for us today. And it is showing where our data generally falls. And it's a little bit easier when I put it in red to kind of see this is the downward pattern of our data. Now it's asking, are there any limits to where your line makes sense? It wouldn't make sense if we went into the negatives, right? So if we went into like, if there was a point over here, that would be like negative 10,000 miles is $60,000. That doesn't make sense. So for part D, I would put negative values wouldn't make sense. All right, part E. It's asking us to do another prediction using our line of best fit. So it says to locate 80,000 miles. So mine's way over here. 80,000 miles, and figure out what price it could possibly be. So mine's gonna be way off because I did not make enough room for my graph.